Hi everyone, I'll be showing you how to do number 45 in this video. So first we want to draw our diagram, the general diagram, which includes both objects. So this is the diagram with a 10 kilogram object on the top being flat and the pulley, the string connecting it to the 5 kilogram object, which is falling. I jotted down some givens that were given in the problem. So we were given that the objects start from rest, they fall 1 meter, and that it takes them 1.2 seconds to fall. This information we'll use later in the problem. For now, let's focus on the free body diagram of the 10 kilogram object. So I drew it here. I defined positive y in the up direction and positive x right because that's the direction that the 10 kilogram object will be moving. So we have the tension of the string, which is going right, acting on the 10 kilogram object. We have the friction force, which is opposing it, which is also equal to mu times normal. And then we have, of course, the normal force and the weight. Weight is equal to mass times gravity. That's why I've just put it as mass times gravity. And our forces are given in these two equations, in the x direction and y direction. So in the x, we have the force of tension minus the force of friction is equal to the whole force, which is given to us by Newton's second law, F equals ma. So the whole thing is T minus mu times normal force equals m times acceleration. For now, we don't know tension, we don't know mu, we don't know normal force, and we don't know acceleration. So if we could find tension, normal force, and acceleration, we could immediately be able to solve for mu. Next, let's solve for the y component of force. So we have, in the y, we have the normal and the mass times gravity, which is the weight. So since the object is not moving in the y direction, it makes sense that we put m times acceleration as 0, because if without motion, you can't have acceleration. So our whole thing is n minus mg equals 0. And when we figure that out, we get n equals mg, which makes sense because if it were any different, and if it were any different, the object would be moving it up or down, but it's staying stationary, which means there's no motion. So the normal force is equal to mass times gravity. And so we get normal force is equal to 10 kilograms times 9.8 meters per second square, which is the acceleration due to gravity, and that's equal to 98 newtons. So we have the normal force. Now let's look at the free body diagram for the 5 kilogram object so we can find tension and acceleration. We'll start with acceleration. So first, the free body diagram. I define positive as down because that's the direction which the object is moving. We have tension acting on it because of the string, and we have its weight because weight is mass times gravity, and it's always present. And we have, so here we want to plug in our givens. We want to use a kinematic to solve for acceleration. So we were told that it starts from rest, which means that the initial velocity is 0 meters per second. We were told that it falls 1 meter, which means that the change in x is 1 meter, and we were told that it takes 1.2 seconds to fall, which means that t is 1.2 seconds. Since we have 3 unknowns, we can solve for since we have 3 knowns, or givens, we can solve for the fourth that is unknown. And we simply use the kinematic change of x equals velocity initial times time plus 1/2 times acceleration times t squared. When we plug it all in, we get 1 meter equals 0 meters times 1.2 seconds plus 1/2 times acceleration, which we're trying to solve for, times 1.2 seconds squared. All of that, when we simplify and solve the equation, we get that acceleration is 1.38 meters per second squared. Now, we have normal force and acceleration. We just need to find tension so that our equation can be complete and so that we can solve for it. And we can do that using our force equation. So the force is equal to mass times gravity minus t because it's going down, and that means that the mass times gravity is greater than t, and it's equal by Newton's second law to m times a. When we plug in all our unknowns, we get that 5 kilograms times 9.8 meters per second squared, which is mass times gravity, minus tension is equal to 5 kilograms times 1.38 meters per second squared, which we got up here using the kinematic. By doing this, we get the tension is equal to 42.1 newtons. Now, we have everything to solve for from this first equation, so we just plug everything in. We have the first equation, I rewrote it, which is the sum of forces in the x direction for the 10 kilogram object is equal to tension minus mu times n, which is the friction, is equal to m times acceleration. And since acceleration is the same, it doesn't matter, it will always be 1.38 meters per second squared. Its acceleration is always the same on pulley problems. So we get that the tension, which is 42.1, sorry, I forgot to change that, just scratch that to 42.1. Newtons minus mu times 98 newtons, which was the normal force, equals 10 kilograms times the acceleration, which is 1.38 meters per second squared. When we solve all that, we get that mu is equal to 0.289, and it doesn't have a dimension since mu is a coefficient. And that is our answer. They asked us for the coefficient of kinetic friction, and that is it, 0.289. I hope this helps. Thanks for watching.